All right, so we're going to continue to talk about the Dalton law, page 3, law of multiple proportion. Make sure you have the definition. Make sure that you write down the reason. How do I know that there's a formula? That is the law. Find the formula is one reason. If they're talking about ratio or whole number subscript, that is another reason. Now, first, we were given two compounds. Compound A has 50 grams sulfur, 50 grams oxygen. Compound B, 40 grams of sulfur, 60 grams of oxygen. Question A asks you, can you show me your data? How do the data support the law of multiple proportion? And then B, if the formula is compound A is SO2, what is the formula of compound B? So we first look up the compound A. Compound A have 50 grams for both sulfur and oxygen. So I cannot tell which one is smaller. So I cannot use information from A. So let's look up compound B. I get 40 grams of sulfur and 60 grams of oxygen. Since 40 grams of sulfur is a smaller number than 60 grams of oxygen, we got to put this smaller number go to the bottom of the fraction. So when I write down the ratio compound A, compound B, I can put 40 grams of the sulfur on the bottom. Make sure you have the element. 60 grams of the oxygen on the top. And since from B I use sulfur on the bottom, I have to do the same thing for the compound A. So sulfur on the bottom, oxygen on the top. I'm doing the simple math. 50 divided by 50, I got 1. 60 divided by 40, I got 3/2. When I compare 1 and 3/2, 1 is smaller number, so 1 will go to the bottom. Compound A will go to the bottom. 3/2 and compound B will go to the top. And so then I set up the ratio. Compound B over compound A is 3/2 over 1. 3/2 over 1 is 3 over 2. Now this number 3 is a whole number. It's not like 3.15. 2 is also a whole number. It's not 2.45 or something like that. So I can answer the part A. Show me the data, how the data support the law. So my answer, like this part, the red part is the work, and the blue sentence is the answer for part A. The data illustrate the LMP because the ratio is a whole number. Again, I say whole number is not 3 over 2. I say the whole number is 3 is a whole number, 2 is a whole number. Now, when I put the S on the bottom, oxygen on the top, since S on the bottom, it has the definition of per sulfur. And oxygen on the top, I can have the statement, how many oxygen per sulfur? How many oxygen per sulfur? It means sulfur would not be changed because per sulfur is always 1 per sulfur. And oxygen, how many oxygen per sulfur? I can have many different answers for oxygen. I can have 20 oxygen per sulfur. I can have 30 oxygen per sulfur. So my oxygen number can be changed depending on what compound. So we keep that in mind. From the part B, we copy from A, compound B over compound A equals 3 over 2, back to here. And I substitute compound A with SO2 because my compound A is SO2. All right. Now you want to multiply SO2 on both sides. So SO2 here will be canceled. And then I will get compound B equals 3/2 times SO2 by multiplying SO2 on both sides. Now because my S cannot be changed, right? Based on my S is on the bottom, have the definition per sulfur, S cannot be changed. And here the subscript for S is 1. Since S cannot be changed, it has to stay as whatever the subscript is. Here the subscript is 1, that would be 1. If the subscript is 2, that would be 2. So 3/2 cannot multiply to the subscript of S. It stays as it is. But oxygen I can change. So 3/2 I will multiply to the O2. So O2 times 3/2. Now 2 and 3/2, 2 and 2 I can cancel. So finally, my compound B formula will be SO3. So what does that mean? I get 3 oxygen per sulfur for compound B. I got 2 oxygen per sulfur for compound A. Okay. Now let me go to the second question. It's the same thing, all right? My compound A, I get less number of phosphorus than chlorine for both compound A and compound B. Okay, the phosphorus is smaller number. So I can set up the compound A, compound B with the P on the bottom and Cl on the top. when I do the math, be careful here. You want to, if you get decimal places, you want to get at least like maybe 5 or 6 decimal places. Otherwise, your number will be rounded too many, like too early, and then your numbers will be cut off. So at least get like 5 or 6 numbers. Okay, so after this, you're going to compare. Okay, my 3.4325 is smaller number than 5.725. So this number and the compound A will go to the bottom, and then 5 point something and compound B will go to the top. So we set up compound B over compound A is 5.7 something over 3.4 something. After I make the division, okay, 5 point something divided by 3 point something, I get 1.66. I need to change the 1.66 to be a fraction. So 1 is 1. 0.66 is 2/3. If you don't know how to get 2/3, 0.33 is 1/3. 0.66 will be 2/3 because it's twice. Okay? Or you know the interval. So 1 plus 2/3, and then I change it in proper fraction to be 5/3. This is my ratio. Then I can write down the same sentence. The data illustrate the law because the ratio is a whole number. Now we can copy this. Compound B over compound A equals 5/3 into the part B. And again, the same thing. I substitute compound A is PCl3. And then I multiply both sides with PCl3. So here PCl3 is cancelled. And then 5/3 times PCl3. Now, based on what we just have up here, P is on the bottom, so it has a definition per phosphorus. We cannot change the P. So my 5/3 will not multiply to the 1, the subscript of the P. P stays as whatever the subscript. But C is on the top, so we have the definition of how many Cl per P. So my Cl can be changed. So 5/3 will multiply to the 3. So Cl3 and then multiply 5/3. 3 and 3 will be cancelled. So my final formula will be PCl5 for compound B. So it means I get 5 Cl per P in compound B, and I get 3 Cl per P in compound A.